Hello, everybody, and we're moving at a pretty good pace. We got spring break coming up in a couple weeks, I think. I'll have to check my calendar. I think it's March 9th or something like that. Anyways, here we are. We're moving right along. We're going to get into more object-oriented principles. We're going to start into inheritance and composition later. Surprise, we're already doing composition. I'm not a big inheritance guy. I find it it used to be it was really cool, but we've evolved in our writing techniques. Java does not support multiple inheritance. We have abstract classes, but the concept we want to talk about is the first two things: abstraction and abstract data type are just going to be concepts. So we're going to talk about ADTs, abstract data types. They're one of my favorite things. And abstraction is by definition pretty cool. But I'm going to leak in a couple things that just for your knowledge base, just so you're like, oh, okay, I've heard that before. When you go to your next class, it's a little more than what we're supposed to be doing, but it doesn't mean that I can't introduce you to them. Like, hey, class, meet abstract data types. Hey, class, meet abstraction. But the whole part of this lecture and this assignment is going to be file input output. Write to a file and read from a file. Write to a file, read from a file. Really, really important thing to do. We're going to use a technique that I like called FileWriter. All right, so there's nothing to it but to get to it. All right. So what is this abstraction? Now this is we're kind of in lecture mode, right? Then I have my coffee, so we're in good shape. What is abstraction? It's just hiding the implementation details and exposing only necessary functionality. Reduces complexity and increases code reusability. And that's by definition, right? So we have these abstract classes and interfaces in Java, and we have things like this in other languages. Java uses this term, abstract classes and interfaces, and they're pretty cool. And if you get into software development and you go work for a bank maintaining their software, you're going to see a ton of interfaces. It's just how we used to write a long time ago. We just don't write like that anymore in industry. But because you have to pay for the sins of us old developers, you have to maintain our bad code. So best you understand what's going on. All right. So abstraction by itself, right? We can have an abstract thought, right? It's abstract. It doesn't really make sense, but we kind of hide it, right? So I don't know how a microwave works. That's my abstraction. I don't. I know I watch Mythbusters. I could probably read about it. I know that it heats up my coffee when I leave my coffee, right? Like I'll leave my coffee in another room and I'll go make another cup. And then later in the day, I'll be like, oh, there you are. So I'll pop it in the microwave and I know it comes out hot. It's hiding the details from me. It just does what it's supposed to do. So our code basically is abstraction. We don't know how the random generator works. Well, we do, but let's say we are doing a game. We don't know how it picks a random number. The users don't. So there you go. We've hidden details from the user and only given them the necessary functionality. So why use abstraction? It encourages modular code. That's why we do object-oriented programming and we write classes and we have really good methods that we put in there and things like that. Simplifies maintenance and updates. Of course, we talked about that earlier. Your job would be to maintain my code. And it enhances security by hiding sensitive implementation details. This gets into algorithmic structures, right? So you hide your algorithms if they're like really good algorithms. You don't want the user to figure them out. And that's sensitive implementation. It's how your code works. So we have these things in Java called abstract classes, and we have these things called interfaces. We're not going to write abstract classes or interfaces in this class. I'm going to save that for Java 3 or programming 3 or 4. But an abstract class can have implementation and what's called abstract methods. We can't initialize an abstract class. We can't make an object out of an abstract class or an interface. Interfaces only contain abstract methods. I take that back. You can make an object out of interfaces after 8, but you cannot make an object out of interfaces. So Java interfaces can have default methods. Don't worry. I'm just introducing you. I know it can be confusing, so that's why we're not going to write it. But in abstract class, you write the keyword abstract, so it doesn't say public. It just says abstract. And then you have to say abstract void make sounds. Now, I don't know if you got into virtual private classes or virtual private methods in C++. Excuse me. I know my class did not. My programming one did not get into virtual private methods because we barely touched with object oriented. But this is kind of the same. It's close to the same thing. Abstract, an animal makes sound. It just does, right? That's the whole thing. So your dog is going to extend animal. This is kind of a version of inheritance. A dog is an animal. So of course the dog's going to make sound. So I just say void make sound. Now I notice, and then system out bark. And you're like, well, that's stupid. Why do I even have to have an abstract class? Because it forces the developer to use the make sound method. You cannot have a dog without it having a sound method. So if I have an abstract class in my software, it forces the developer to use that method inside the abstract class. Just a, hey, introduce you type thing. So what it does is this would do anyways without the extend animal, but we're forcing it to use the abstract class because we have extends animal. Kind of inheritance type thing. All right, that's enough abstract classes and stuff like that. I'm just saying, hey, these are abstract classes based upon abstraction. So it forces us to use different things. But what we have are abstract data types. Okay, and these are ADTs, and these are really important. In your next class, you're going to do a class called Data Structures and Algorithms, one of my favorite things to teach. And we get into different ADTs or abstract data types. And I know we do an array list and an array, and those are great. And I've had some people that have used hash maps and things like that. So I had to talk to them about it. But we also have stacks, queues, lists, sets, map sets. Again, hash maps, map sets, things like that. Graphs. All these things are abstract data types. So a stack is really cool. In a linked list, our array list is like a linked list, except a linked list can be a circular linked list or a doubly linked list, and our array list is more of a doubly linked list than a singly linked list. You'll learn so much more about that when you get into algorithms and data structures. All right, but let's talk about a couple of these simple abstract data types that we use. So a stack, what we do is we'd include stack. And now that I've introduced it, if you find you need a stack, use a stack. Stack's really cool. Stack in Java is awesome. Import utility stack. Now, you've seen me do this a million times. Utility.star, probably not the greatest programming shortcut that I've ever given you, but I would go ahead and keep it until your next instructor tells you. You can just blame it on me. But it's just like array list, right? We're just importing an array list, and all we're doing is initializing the stack just like we initialized the array list. That's it. We initialize the stack just like the array list. We just said stack. And notice it's a wrapper class, so it has a capital integer fully out. So if you want a stack of doubles, capital doubles, stacks can only hold objects. Equals new stack. Cool. Now we put things in a stack with push. And stacks are a stack of plates. Stacks are first in, last out. So 10 is here, 20 is here, and 30 is here. I cannot get to 20 or 10 until I remove 30. Right? So I can peek at what's at the very top, and that just doesn't remove it. But if I pop it, that means it pops it off. So versus C++'s stack, where C++ always has return on pop, it doesn't have a peek, always returns value. We do not return value on peek. We delete with pop. We print with peek, and we delete with pop. So we can just say, we can run stack, and then so stack after pop will tell me the top. Stacks are really cool. We use stacks for all sorts of algorithms because it's super fast. It's what we consider O to the 1. And you'll get to that when you do algorithm efficiency. Big O notation. Q is like a stack. Look, I'm putting in a linked list and a queue. Okay? Because a queue is a linked list. So I have to do a linked list and queue. Now what a queue does, queue is different. Queue is first in, first out. So it's like you're getting in a line. So when I add a queue, one goes here. And then when I add to the queue, it goes here. And I add to the queue, it goes here. And I add one more if I wanted to, it would go here. When I go to the queue to peek, it can only see the very first thing that I put in. So just like you go to a printer queue, right? The first print job that gets to the printer queue is the first one that gets printed. So if you send a whole bunch of ones to the printer queue, it's first and it gets printed. Okay, and we have different things. We add to the printer queue, and a linked list just means that this sees that and this sees this. The queue is what we consider a linked list insert end, because everything goes to the back of it. So you put it in, it goes to the back. Kind of like we do with our array list, just a list. And I can peek and I can pull, and pull is the queue's version of pop. It just gets rid of it. So when I pull this, one goes away, and if I peek, I'm at 2. So that's a queue. Queues are pretty neat. We use queues and stacks a lot for shortest path algorithms. Depth first search, A star, all sorts of short, Dijkstra's, Floyd, whatever shortest path is your favorite. That's what we use stacks and queues for when we have a graph and we want to find the shortest path. All right, more on that if we get to it. This is the heart of it. This is what we're really going to worry about. We're not going to, I just want to introduce those things because it's kind of in the flow of what it is. If you played that, if you're watching this at twice speed, please stop and play at regular speed now, because here we are. We're going to write files, and we're going to write to a file. And writing to a file in any language is important because when you don't write to a file, you're not saving data and you can't use larger amounts of data. You don't want to, if I said, hey, I want you to write a program that has has an array of 350 strings. You don't want to type 350 strings in. So what do? You get a file and you copy and paste 350 words onto it, and you just read the file and write to it. And then it's there every single time, right? And you change the names if you want to. So having being access to file writing is really, really important. Now we're going to write. This one is writing. Now this one, it doesn't have a switch on this write, and I'm going to talk about that in our example. So it would go right here. So what do? We must import Java file writer, and we must import Java IO exception. This is a good time for us to not use the star. Okay, so we got file writer and IO exception. That's input output exception, and that comes with try catches. And we need try catches. And what try catch does is says, hey, try this. If it doesn't work, tell me why it doesn't work, right? So the IO exception and the catch will whatever error will be stored into E, and then we're just going to go print stack trace. And stack trace is what happens to the queue when we're done. So if something goes wrong, I can see what's wrong. Especially with file input, right? Oh, I didn't include the file. I have the file name wrong. All these sort of things. So try catches are really, really important. I would get comfortable writing them if I were you, if you're moving into software development or computer science. If you're comfortable with try catches in your second programming class and you go to your third programming class, your instructor is going to be very happy with you. I'm happy with you because you guys are awesome. I'm having a lot of fun. I wish we were in person. It's a fun class to teach in person. We have a lot of fun. Anyways, it's not. So we're going to include these two things in our Java input-output, right? IO exception and file writer, because we're going to use file writer. I find file writer easier to use. Here's my class called file writer example, and I, of course, have my main. So inside my main, I say try, and then what do? I've imported file writer, so I say file writer. You're going to build an object called writer, and it's going to equal new file writer, and then it's going to be for the text file output.txt. Now here's what's cool. If you don't have a file, and I'll show you when we do our example, Java's just going to go ahead and build a file for you. It's going to be like, hey man, I'm going to just go ahead and build a file. Best scenario is you just build a file, but Java will look at it and be like, all right, I'll build the file for you. I don't care. So Java's pretty cool that way. C++ does the same thing. C# does the same thing. They're all pretty good about using the file writer to write a file. Python does it. JavaScript doesn't, because JavaScript sucks. Anyways, sorry if you're going to be a web dev kid, but don't do that. So I've created an object called writer using FileWriter class, and my object is called writer, and it's going to write to an output.txt. So now I just say, hey, writer, yeah, what? Do you have a write method? And the writer says, yeah, I got a write method. It's in the FileWriter class. You want to use it? And he's like, sure. He's like, what do you want to write? And he's like, I want to write hello, Java file writing. And it says, okay. Notice these are strings, so it just writes it. Pretty simple. It just, this method right here, just writes. It writes whatever I tell it to. And then you can have these are kind of cute, file written successfully, and because we don't see it. And then if we had an error, it'll catch it and tell us what it is. That's relatively simple. That's how we write to a file. Now, I mentioned earlier with the switch, and I'll show you this when we get to our thing, but right here, this will just append. Every time I run this, I can't write more than multiple things. It just keeps getting in the way. So we are going to, one second. Very good. We're going to figure out a way to write, to add things to it, right? Because you don't want to keep overwriting your files. Well, you need to add things to it. So I'll show you how to append to a file. Well, writing to a file is good, but we need to read from our file. So, hey, there's our guy, file. We're going to use that. You use file not found exception. That's another IO for a try catch, right? So you don't find the file because you're trying to read to it. So reading means that you have to find the file. If you can't find the file, you're just going to be like, hey, there's no file, man. And so these are what our imports are going to be. We already know scanner because we're going to use the scanner class to read. That's pretty simple. And it's a try catch. Again, try, scanner, and then you can use scanner SC. I'm morally with SC, but you can use scanner. Equals new scanner. And then instead of how we did our input, we're just going to say new file. And notice file is capitalized because we've included file here. So new file, and it's going to find output text. If there's no output text, file not found exception. While scanner, while, it's just a while loop, right? While scanner has next line, what that will do, and we have a next, right? You can read individual words, or you can read the whole line. So has next line, while scanner has next line. So that opens up the file output. There's a file here. And it's going to output every single line because it's going to go to not truncated white space. It's going to go to the return. So every line is going to print out. So I'm just going to system.out printer scanner, which we have, and then next line. So scanner has next line, gets stored into this, and then we print it. So we print this one, this one, this one, this one, this one. While scanner has next line, there's no more lines to print. The while loop is no longer true, and we're out. So I can read every single line of my file. Now, here's the thing, and this is what's really cool. If I can read a file, if I can print a file, if I can do this right here, if I can print, that means I have access to. So if I can print, I can store. Go back to Lucky 7. What was our last one? We took words from a file and we stored it into an array. Or an array list. I think it was an array list. Yeah, you got to pick the size of it. So if we can access it, if you can read a file, if your program can read a file, you have access to that data. Meaning if I can read the file, I can grab that data and I can use it in my program. I can store words, integers, numbers, data, whatever I want. I can use it in my application. Files. Kind of feel like the ICP. Magnets. How do they work? So here we go. Pretty cool stuff. we write to a file, we read to a file. We're going to go over these examples. So how do I handle these input-output things? Use try-catch. Try with resources is okay, but use try-catch, and you have the file not found exception and the input-output exception. So use your try-catch, okay? That's you want to handle errors like a pro, and that's how you do it. Use try-catch. Why do we use abstract data types? Modularity, encapsulation, reusability, right? You will find that an array is okay, but it's not. It's still the king of and queen of data types, ADTs, but it's limited. It's too much work. We have stacks, we have queues, we have maps, we have sets, we have graphs, we have trees, we have all sorts of data types, and they are much more efficient. So when you start writing code in efficiency, good. Also, you need to know abstract data types if you're getting into leet code or if you're going to have an interview soon for an internship. All right. Why use abstraction? It just makes it your code functionality is better. That's about it. Adding new object types become easier because they extend the abstract class. Again, this is just information because we're not writing abstract data types or abstract classes. But you should be exposed to them. So here you are, abstract classes. But the big thing is we're going to do our file input output. That's important. Real world use file input output, reading and writing file is really important. Most applications need outside data that can be stored outside of memory. So the application starts again, it can access the data created during runtime. So we're going to have a Final Fantasy game that you're going to write yourself, and you're going to design it and do all you want. You're going to have to read from a file because you're going to have to save your game, right? You're going to have to save your progress, your hero health, whatever weapons they have, whatever you want to do, you're going to have to save that to a file. So when you start your game, you can say, hey, I want to start with the same guy that I had or gal that I had last time, or unicorn, whatever it is your game's going to be. And then you can save that from a file. You can write it into your game and initialize your stuff. So it's really important that we get input-output. Okay, next is just going to do some code for that, and we're going to take a look at things, and then we got homework helper, and right on. All right, I'll see you at the compiler. Hey, everybody, this is going to be pretty quick because, it is, because we're going to save a lot of this for homework helper. But it's just a good thing to kind of get you started. You can do this, and then you can kind of modify this to do your homework stuff. But I want to go over what we just talked about in lecture. We're going to import our java.io, and then we're going to use file writer. Okay, that has to end with this. I'm going to do a couple things just to expedite this a little bit. And so I think I'm going to have 4 of these IOs. File writer, I'm going to use input output exception. IO exception, and I got 2 of those. Then I'm going to need a file. And I don't need 2 of those. I got file, I got IO, and a file not found. Not found. File not found exception. Okay, file writer I'm going to use, IO, file, those 2 are paired up with each other, and because I need scanner. Scanner, you only have to import scanner once, and then that's pretty cool. All right, so here we are in our, we have everything we need. So let's look at a couple different things. Let's start with a string. Because we'll do a user input. User input in homework helper. So I'm just building a string right here, and it's just a string in X. So that's pretty simple. Nothing new there, but I'm going to write that to my file just for kicks. So I'm going to try, and in my try statement, and again, this will be in a text file for you guys to play with. In my try statement, I'm going to use FileWriter. Do I have 2 T's? I'm going to use FileWriter, and I'm going to create an object. And that's going to equal new. And I'm going to build a beep. Yeah, that'll work. And what am I going to call it? I guess I'll just call it output.text. You can call it whatever you want, but that's all it is. Now this statement, it doesn't end here because it's a try, so your bracket goes here. Right? You don't put a semicolon there because you're not done. And then I'm just going to write writer.write because I want to use the write method. And I'm going to do a new line, concatenate, and then whatever I want. See, I can just write whatever I want. Now that's a statement, so that's going to end. Well, I can also write and I'll do a new line. This is an escape character. And I can also write variable. So what does that mean for me? Well, this is just me declaring it and assigning it value right away. If you wanted to do user input, you just do user input and then just write your variable. Just have the user type in what they want to type in, store it in a variable, and then bam, slam it into the write file. That's pretty cool. And if you want to, you can pring line. If you want to, you can let you know that it's successful. Things worked out. T-H-I-N-G-S. Things worked out. So I'm just going to write a couple things to my file, and I'm going to get to something really quick after that. Now, if that didn't work, I need a catch. So my catch is going to be my IO exception. Right? And then I'm going to store that thing into E. And then E is going to do print trace. You get an error, you can always check your stack trace. That's what that does. All right, make sure all my brackets are where they need to be. Perfect. Now I write to a file. If I run this, it's just going to write to a file, right? It's just going to write. Well, first it's going to build a file and see what errors that I got. Oh, it didn't break. So here's my output text. Remember I said it'll build a file for you. It just wrote it for me. If I delete this, beep, then Java's going to be like, I'll do it for you. I didn't even make a mistake. And that's what I wrote to my file. I have my file. This is what's going to be written to a file. This is just a string variable called X. I can write as much stuff to my file. You'll notice if I run this again and I go over to my file, it's just going to say things worked out. If I go to my file, that's all there is. Now that's kind of silly because it's rewriting it. But if I throw a switch and I make this true, this means I can append. I can add to it. So if I run this, notice I have this right here. If I run this, it's going to add to it. Just going to add to it because I'm saying true. I'm saying I give you permission to append it. Hey, if I want to just write once, I take my true away. And we'll go over this more in Homework Helper. And that's just one thing, right? But if I want to append, I make it true. Now, let's say I just want to get rid of everything in my file, right? Well, just don't write to it. Look, I'll erase my stuff. Things worked out. Oh, they're gone, right? So you can erase, you can delete all your stuff in a file if you want to. That's pretty cool. Anyways, that's just if you want to append, you're going to do true. Well, we wrote to it, Let's make sure we're where we need to be. So let's read from it. And this couldn't be simpler. Try. Gotta try. Everybody try. This looks familiar, right? New scanner. And then I'm going to be using new and then a file because I imported file right up here. Remember that? I imported file. And what is the name of my file? Output.txt. So it's got to be the exact same. If not, I'm going to get an error, and we all know we don't want the errors. And now I'm trying, and here's my while loop. While what? Scanner, or SC, has next line, method. And while this loops, because this just stays in my file, while I have next line, and we don't have to go through the whole thing, once your file is open, your scanner can pick one line. You don't have to read through the whole file if you don't want to. We're just going to print. And what are we going to print? We're just going to print whatever is holding, whatever the SC object is holding. And that's the line that it has until it runs out. That's pretty cool. Make sure I'm staying within my stuff. That tries there. That while loop's there. After that try, I'm going to do a catch. And my catch is file not found exception. And I'll store that in E also. We use E because why? E is error. E is for error, right? And then we go E dot. And sometimes it's fun to just throw an error and then go see the stack trace if you want to. But if I run this, I have nothing in my file, but I am appending it. So I'm going to get that, and it should store it unless I throw an error. Now look what it did. It took the stuff that was in there and it read it and it printed it out. And if I do it again, because I have it set to true, it's going to print it out again. If I want to add user input, so easy, right? Just SC, just declare a string and then have you type something in. Use your SC next line, has next line, and you're in. All right, I'm going to save a bunch of this because we're going to go over our homework stuff in the next video. And that's going to, I don't want to do the same thing twice. Okay, type this in, play with it, get your files going back and forth. When you're doing that, after you've written to the file, when you're reading from a file, instead of printing it, store it into an array or store it in an array list or do something. Don't print it, just build an array list up here. And then from the array list, store it into that array list, right? So just put it in the array list. And then you have it stored and you can manipulate it. Try without the while loop. Just do, open the file and access the first line. See what's going on. Do has next instead of has next line, right? I think it has next. I have my, yeah. Right? So just play with it. All right, that's it. I'll talk to you guys later. Bye.